All right. Good morning, class, and welcome to another screencast. This time we're looking at systems of inequalities. It says continued on the notes because this picks up from the Edpuzzle video that you watched yesterday, and it's going to explore what happens when we take two different inequalities that each have two variables, so we can put them on the coordinate plane, and we graph them together. So just a couple quick reminders. If we look on the coordinate plane, and we explore just a single inequality, like y is greater than or equal to x plus 5, we graph the boundary line that would contain answers because it's greater than or equal to, just like we would a linear equation. So we kind of treat it like y equals x plus 5 right at the beginning. So we'll go, okay, our y-intercept is up 5. And then our slope is just 1 over 1 because we don't have anything other than the 1 in front of x. So we'll plot our points. And because it's greater than or equal to, our boundary line will be connected. Now we have to decide, okay, what points or values of x and y make this inequality true? So we can get rid of our boundary line equation there and just think about the inequality. What values for x and y would make this true? The easiest way to do this is to pick a test point, and I really like 0, 0 because it makes it quick, simple math. So 0 is greater than or equal to 0 plus 5. Well, 0 is greater than or equal to 5. That's not true, so we don't shade where that point was. We shade to the opposite direction. So everything above the line is going to make this inequality true. For example, if we pick a point, let's say where x is 0 and y is 10, and test it out, well, y is 10. That's greater than or equal to 0 plus 5. 10 is greater than or equal to 5. That's true, and that point falls right up here, so it makes our inequality true. You can always determine whether your shading will be above or below the line based on the inequality symbol. So if it says y is greater than, you're always going to shade above your linear inequality. If it would say y is less than, you'll shade below that line. So that's a review looking at just a simple linear inequality. We can also have quadratic inequalities, and that's something we studied yesterday as well. So if we look at a coordinate plane again, and this time we look at it with a quadratic inequality. Let's say y is less than or equal to x squared plus 3x plus 2. We treat it very similar to that linear inequality. We need to graph the boundary line basically like it's an equation. A lot of you are probably tempted just to rely on your calculators. Don't forget the other methods we have. We've been factoring a whole lot, so we can think about how factoring could get us this graph. If you go ahead and set up your rectangle to figure out the factors, you'll put x squared and 2 in the corners, and then we're looking for what multiplies to 2x squared that adds to 3x. Well, I think 2 and 1 with an x next to them are going to give us that. So let's put those in our rectangle and then pull out the greatest common factors, and we'll see the factors here are x plus 2 times x plus 1. That'll be equal to y, but in this case we're trying to get our x-intercept, so that's where y is 0. And then using the zero product property, we'll see that x is equal to -2 and x is equal to -1. So that went quickly, but those are things that we've done for a while now, so really this is just a review. So if we go in and we put in our x-intercepts, I'm going to go by a scale of 0.5 just so we have a little bit of room in there. We'll see intercepts there. We can get an idea where the y-intercept is at by putting 0 in for x. When it's all said and done, y will be equal to 2. So I guess I'll go by 0.5s here as well. And then the last thing we really need to make this look all right would be the vertex. I can tell based on where the y-intercept is, the vertex will be below the x-axis. To actually really figure it out though, remember we can average the x-intercepts, meaning if the x-intercepts are at -2 and -1, I know the vertex will be at -1.5, and that's a value I can plug in. So let's do that. Let's clear a little space. And then that means that we're solving for y when x is 1.5, and it's negative, excuse me. So if we work with that, well, y is equal to -1.5 squared is positive 2.25. 3 times -1.5 is -4.5. And then 2 is just 2. So combining like terms here, we actually end up with just -0.25. So when x was 1.5, y is -0.25, that's our vertex. That's going to sit right in here. And just like that, we've got enough to sketch our parabola. All right, all that was just for the boundary line of this inequality. So we've graphed it like it was a parabola, but remember, it wasn't really an equation. We go all the way back to the beginning that we were given an inequality. Since it says great or less than or equal to, the points on that parabola make this inequality true. We just need to decide, do we shade inside the parabola or outside? To do this, let's pick that same easy test point of 0, 0 and see if it makes this true. Well, those cancel out. So we have 0 is less than or equal to 2. That's true, meaning we shade over top this and all outside of our parabola. So nothing goes inside the parabola, and that, remember, goes on forever. So nothing goes in there, but everywhere outside are the points that will make that inequality true. So separately, we just looked at a linear inequality and a quadratic inequality. The thing with a system of inequalities is we have to combine those two ideas. So if we jump over, let's look at, on Desmos, this idea. I've actually already put those inequalities. Let me change those to greater than or equal to, though. Whoops. So to do that, here we go. We're going to adjust our sign, greater than or equal to, and that's less than or equal to. So if I just graph one, you'll see just what we saw when we graphed on our paper for the linear inequality. Now if I graph my second inequality, that blue shading is what makes it true, that quadratic. The only place we're interested in for the solutions to this system are the points that make both of these true. So the things outside of the parabola make it true. The things above the, or things I should say, points above the line make that inequality true. But only the points above the line and outside of the parabola make the system of inequalities true. So that's a whole system of inequalities with all those points that are outside the parabola and above the line, making that inequality system true for each of those. That is how you show your solution set here. You can do this whether you have two lines and it's a linear system of inequalities, or you could have a quadratic in the line, you could have two quadratics. Truthfully, you could have any types of inequalities you like put together in a system. You're going to practice these ideas a little bit more today on the worksheet attached on Google Classroom. As always, be sure to take advantage of office hours if you have questions. Good luck.